Hey guys, this is the short video of the last few slides that I promised you on those examples. So I don't like these American units, these inches and miles, because they are not standard units. This is also not standard units. Standard it would be radian per second, but I can deal with that. I just can't deal with these ones, inches and miles. So I'm going to, and in the future I will change the text to read centimeters and kilometers for inches and miles respectively. So it has a diameter of 32 inches. It's traveling at 60 miles per hour. So let's say that its linear speed is 60 kilometers per hour, right? And I know that the standard unit is supposed to be meters per second. So just keep that in mind. They want me to find the angular speed of the wheel in radians per minute. How many revolutions per minute do the wheels make? So they want me to find its angular speed in radians per minute. We know that V is equal to omega times R. I already have the V, it's 60 kilometers per hour, right? I want the omega in radians per minute, and I'm going to multiply that by the radius, which is half of the diameter. And remember, diameter is 32 centimeters, so the radius will be 16 centimeters. Now I have units here. Sorry, this was kilometers per hour. I'll just put that there. I want to find my angular speed in radians per minute. So I just need to make sure that my units are consistent. I need to make sure that my kilometers are changed to centimeters, right? And my hour is changed to minutes because I want the angular speed in radians per minute. I'm just going to make sure that my time is changed to minutes, my kilometers are changed to centimeters, or the other way around, centimeters changed to kilometers. That way the unit will be consistent. So I know 60 kilometers is the same as 60 times 100,000, and that changes it to centimeters. This per hour is 1 hour has 60 minutes, so that's divided by 60 minutes, is equal to omega times 16 centimeters, right? I hope you can see that the centimeter unit cancels out. Centimeter unit cancels out. So I'm left with 60,000 times 100,000 divided by 60. And if I want to make omega the subject, I'm also going to divide by 16 this side and at the same time by 16 this side. So my omega at the end of the day is 60 times 100,000 divided by 16 times 60. And my answer is going to be in radians per minute. Okay? So, yeah, that's how we can work that out. You get your calculator and figure out what this becomes. That will be your answer in radians per minute. How many revolutions per minute do the wheels make? Let me work this out, see what it gives me. I know that some of you might have used or might want to use inches and miles. I do not like those conversions because they're not standard. So sticking to the standard ones. And remember, the idea of this example is to get you to be able to interpret this information and use it appropriately. So, yeah, 100,000, sorry, 100,000 divided by 16 times 6. So my answer is 62500 radians per minute. That's the angular speed in radians per minute. If I want to change it to revolutions per minute, I know that because this is radians per minute, I know that one revolution is equal to 2 pi radians, right? If one revolution is 2 pi radians, how many revolutions will be in 62,500 radians, right? I know one revolution is 2 pi rads. I'm trying to figure out how many revolutions are going to be in 62500 radians. How do you do that? I hope you can see that I will divide 62500 by 2 pi to get revolutions per minute. So I'm going to divide 62500 by 2 pi. By 2 pi. Divide by 2 pi. And that gives me 9,947 revolutions per minute. That is my angular speed in revolutions per minute. So this truck wheel does 9,947 revolutions in 1 minute. You can take that further to try to figure out how many does it make per second. And I hope you guys know how to make that conversion. All right, the next example was kind of similar. A wheel of radius 8 inches. Remember, to me these are centimeters. Rotating at 15 degrees per second. What is its linear speed, v, the angular speed in RPM and the angular speed in radians per second? So, first of all, I've been given the angular speed is 15 degrees per second, right? But I need to change that to a unit that I know, and the unit I know is radians per second. That is the standard unit for angular speed. So changing 15 degrees to radians, I'm going to multiply that by 5 and divide it by 180. And that answer is going to be the angular speed in radians per second, right? So 15 times pi divided by 180 gives you a fraction of 15 divided by 180, fraction 1 out of 12. Okay. My answer is pi out of 12 radians. Sorry. What's happening? What's going on? 12 radians per second. Yeah. So what's my answer in radians per second? Now, if I want to change it to RPM, revolutions per minute, this same answer is in radians per second. I need to change it in revolutions per minute. Remember, 1 revolution equals 2 pi radians, right? So I need to first change this figure, the pi out of 12 radians, into revolutions. How do I do that? If 1 revolution is equal to 2 pi radians, that means I'm trying to figure out revolutions in pi out of 12 radians. What do I do? I hope you guys remember. I'm just going to divide pi out of 12 by 2 pi. So the number of revolutions will be pi out of 12, divide that by 2 pi. And that answer will be pi out of 24 revolutions. Sorry, 1 out of 24, not pi out of 24. Because the pi cancels out. It will be 1 out of 24. It's just, if I do the KFC, I know some of you might be confused. It's pi out of 12 times 1 out of 2 pi, right? The pi cancels out. And then you're left with 1 out of 24 revolutions, right? So 1 out of 24 revolutions. What about seconds? How do I change seconds to minutes? So my answer is currently in revolutions per second, but I know that 1 second, this 1 second has 1/60th of a minute, right? 1 second is a 60th of a minute. So it's 1 out of 24 revolutions divided by 1/60th of a minute. I hope you can see that my final answer is going to end up being, make this smaller. Final answer is going to end up being 60 divided by 24 revolutions per minute, which reduces to 5 out of 2, or 2.5. 2.5 revolutions a minute. I hope that makes sense. Last one, a CD has a diameter of that. When playing audio, the angular speed varies to keep the linear speed constant. Okay. Where the disk is being read. When reading along the outer edge of the disk, the angular speed is about 200 RPM, right? 200 RPM. Find the linear speed. So 200 RPM, remember revolutions per minute, angular velocity is equal to 200 revolutions per minute. Find the linear speed. And I'm going to work in, we have that millimeters. So remember, we'll need to change this to meters, which is multiplying by 10 to the minus 3. Yeah. So remember, 1 revolution is equal to 2 pi radians, right? Hope you remember that. So that means that 200 revolutions will be 200 times 2 pi radians. What else do I know? I know that 1 minute is equal to 60 seconds. So I'm going to substitute those conversions into what I was given here. So instead of 200 revolutions, I'm going to have 200 times 2 pi radians. And instead of a minute, I'm going to have 60 seconds. So my final answer is 200 times 2 pi divided by 60. So basically 200 times 2 divided by 60, 400 divided by 60 is 20 out of 3 radians per second, or pi, I think it's a pi. 20 out of 3 pi radians per second. Now, if I want to write that in terms of decimal, that is 20.94. Yeah, 20.94 radians per second. That's without the pi. So, next thing I need to do is find the linear speed. I know that linear speed is given by V equals omega times R. I already have the omega right here. This is my omega. I just need to multiply it by the radius. And the omega is in standard units, which is radians per second. So I just need to multiply it by the radius, which is 120 millimeters. But I need to convert that to standard units, which is meters. So that's 20.94 multiplied by 120 times 10 to the minus 3. Times 10 to the minus 3 is the same thing as dividing by 1,000. Because if I want to go from millimeters to meters, I divide by 1,000. So when I work this out, I have 20.94 times 120 divided by 1,000, 2.5 something, 513 meters per second. So that's the linear speed of the disk of the CD. Hope this helps, and this was the homework. Maybe, hopefully, you can have it done before you come to class on Friday, Monday. Yeah. Bye.